Hello, today let's read about fine-tuning segment anything model. SAM model. Simply, SAM model is the open source. Main contributor of this model is Facebook Meta. Meta has released the weight research paper and, and the approach how they train the model. You can find this model in Hugging Face. Now let's learn how to fine-tune the SAM model. What is SAM model? SAM model is used for the precise image segmentation tasks, and it has pretends the SAM model is very good at segmenting tasks using the prompt segmentation. Now let's look here. Extracting fine-tuning model process is as follows: extracting the same component. Then we have to create a custom dataset. We have to pre-process the dataset and set up the training. Set up the training. That means we have to fine-tune the hyperparameter and other parameters in the model. Train learning rate, weight decay, and which optimization function need to be used. It is all in the training setup process. We do all the hyperparameter setup in the training step. Then we go to the training loop and optimization step. We do the training and check the loss and validate it with the validation dataset to get the best parameter available and best model for the task. Then we say save the checkpoint, and after the model is fully fine-tuned, we deploy it. Let's read the other. What are they given here? The segment anything model is the cutting edge AI tool designed to revolutionize image segmentation tasks. By dividing the image into meaningful segments, SAM enhances object detection, analysis, and making it invaluable across the industries such as medical imaging, autonomous driving, and more. Given the image, we pass into the image encoder, which create the image embedding, which is latent for space of the image. The image we give to the model is very large when we are doing the inference or model. The image we are giving is very large, so we have to encode the image to the latent space, and given the we create the image embedding, and using the image embedding and prompt encoder, which encode the prompt. And the prompt can be here. Prompt can be many things, not just the when you are saying the in LLM text-based prompt. It can be a point. You specify the point, and the say the segment anything model encode segment the region across the point across that point of matching object, and that can be box, and that prompt can also be text. And the segment anything model gives the segmentation of that image at the point or the box or based on the text. However, to maximize its potential for the specific application, fine-tuning SAM is essential. In all the cases, in most of the cases, when we are doing the general tasks, the pre-training model is good enough. But when you are performing the tasks, domain-specific tasks, the fine-tuning becomes essential because the training of the model is done in large amount of dataset containing the vast range of data, vast range of knowledge. So when we want to specifically make the model do better at this specific domain, to get better accuracy, we have to fine tune the model. In this let's read. In this block, we'll explore the importance of fine tuning SAM, delve into one certain learning approach for efficient fine tuning, guide you through the process to improve the performance on specialized dataset. Whether you are working with the limited data or seeking high accuracy, this guide will show you how to fine tune the SAM for optimal result. What are the key features of the SAM? What are the key features of this segment anything model? Versatile image segmentation. SAM is highly versatile and can be applied to the various image segmentation tasks, whether it is segmenting the object in everyday photographs such as medical scan or satellite imagery. SAM delivers high accuracy and efficiency because the SAM model itself was trained in the 1 billion marks. So, in addition to the SAM model, they have also released the training dataset, which is big contribution to the LLM, which is big contribution to the open source community. So that because it is trained using the vast amount of knowledge, the tasks and performance, it can be used in variety of variety of different fields such as medical scan, photographs, satellite imagery, yeah, and high precision. SAM architecture is designed to deliver high precision in identifying and segmenting the object within the image. This precision is crucial in application where the minor error, such as in medical diagnosis or autonomous vehicle navigation, can have these significant consequences. Yeah, high precision, you can understand in a way, because SAM not only segment the image, it can also segment the image based on the prompt. And what can be the point? We can specify the prompt as a point in the image, so that it can efficiently and with high precision segment the specific region of that point in which that we are specifying it. And we can also give it the negative label, so that it do not cross the boundary and segment the anything that we do not like. It is important in the field such as the medical diagnosis, where the accuracy is very much needed, because even the minor error can have the fatal disaster during the medical diagnosis if it is not done properly. So that SAM architecture is very good and can be used in the different fields. Scalability. SAM is scalable, meaning it can handle the large dataset, complex images without significant loss in performance. This scalability makes it suitable for the small project and data intensive application. Adaptability. One of the SAM strengths is adaptability. It can be fine-tuned to improve the performance on the specific tasks or dataset, making it an invaluable tool for the specialized application. That is, basically all of the model have the adaptability to fine-tune fine-tuning the model to improve the performance on the given specific domain or the specific tasks, specialized application tasks. Unless here is the significance of the fine-tuning. Fine-tuning is adjusting the pre-trained model to better suit a specific task or dataset. For SAM, fine-tuning is particularly significant for the several reasons. Enhanced performance. While SAM is highly capable out of box, fine-tuning allows it to be optimized for the specific tasks. This optimized can lead to the significant improvement in performance, such as higher accuracy, faster processing time, yeah, and task specific customization. Different tasks often require a different approach to segmentation. Fine-tuning SAM enables it to be customized to the unique requirement of specific tasks, whether it's identifying the tumor in medical image or detecting obstacle in autonomous driving scenario. It is meaning that when fine-tuning the model, we can fine-tune in a specific way so that it can get the high accuracy and precision in the particular task, so that it can be used for the unique requirement of the specific task, to which provide the better segmentation, yeah, which provide the better accuracy, precision for the specific tasks, for the specialized application, in such as in autonomous vehicle, detecting the image of the person walking in the road while driving. It is important in various field. Improves generalization. The model can generalize to new unseen data by fine-tuning the same on diverse set of example. This means it can maintain the high performance across the variety of condition and image type. We can say that since this SAM model is trained using the 1 billion marks parameter, 1 billion marked images, so that we can confidently say that it is better than the other models. It has better generalization capability, since the model parameter is also quite large. There are two or three weighted version of the SAM is been released. One is base, one is large, one is small, I think. And since it is trained in the large amount of data, and where we can get large amount of data, most of the data are from scraped from the internet, and you can get different amount of different data from the different domain, so that during the pre-training phase, it has the very strong generalization capability, so that it can maintain the high accuracy in the generalized tasks. Reduce data requirement. One of the most potent features of the fine-tuning is ability to achieve the excellent result even with the limited task-specific data. This is particularly valuable when obtaining the extensive annotated data. Annotated data set is difficult or expensive. Yeah, if the data set is difficult or expensive, we can see that here is method per SAM, prompt to being adapter LoRa 3 weight marks per SAM F, parameter per SAM 0, 20 prompt tuning 12k, adapter 193k, LoRa 293k, 3 marks weight 3, and per SAM 2 parameter. And we can see the MIOU of the all the result based on this, and we can see the best performance is using the method of the LoRa. One of the best method is LoRa, and then the per SAM F and 3 marks wide, with the maximum being of per SAM F. Yeah, method fine tuning it using the per SAM F, it has getting the better accuracy performance compared to the other. One shot fine tuning. What is one shot fine tuning? This user provide one image, one marks, and do the one shot learning, and give the another image similar to that image, and the model will generalize better for that image. That is one shot learning is machine learning paradigm where the model learns its information about the category from the minimal number of examples, often just a single instance. This contrast with the traditional method that requires the extensive dataset with the numerous amount of example to achieve the high performance. In one-shot learning, model leverages the prior knowledge from the previously learned tasks to quickly generalize and add to the new tasks. This approach mimics the human learning, where people can recognize and categorize the new object after seeing only once. Advantage over the traditional fine-tuning method. What is the advantage of one-shot learning? Efficiency. Traditional fine-tuning method requires the vast amount of data and extensive computational resources. One-shot learning significantly reduces the data and computational power, making it more efficient. Speed. One-shot require fewer examples so that the model can be trained faster. And this is crucial in time-sensitive application where quick adaptation to the new tasks is needed. Resource optimization. Since once near the pure data set. That means we do not have to collect, we do not have to work to collect the different large amount of data set, which optimizes the collection and pre-processing time. And since the model is the model is only trained to learn train with the few data set, it optimizes the cost for the fine tuning and optimization. Robust generalization. One such encourages the model to generalize further from the limited data, potentially leading to the better performance on the unseen data compared to the fine tuning on the large specific data set. How to fine tune the SAM model with once learning? Yeah, how to fine tune it? This is the same. We have to create a data set, pre-process the data set, and train. After pre-processing the data set, we have to train and optimize the hyperparameter, then save the checkpoint, and the model is ready for the deployment. One of our client approach here is the given the brief article, or one of our client approach us with the unique challenges. They need to improve the segmentation of the ships from the aerial images using the SAM model. By fine-tuning the SAM with the once learning, we tailor the model to handle specific tasks efficiently. There's where this step follow to integrate the fine-tuning strategy in our model, extracting SAM component. To fine-tune the SAM model for the SIP segmentation tasks, we extracted is three component: image encoder, prompt encoder, and max decoder. The SAM model has the three component: image encoder, prompt encoder, and max decoder. This allows us to prepare the max decoder for fine-tuning using the principal outline in the one shot fine-tuning approach. Creating the custom dataset. Our client provided the dataset comprising of aerial images of the ship, ground truth segmentation marks, and bounding box around the ship. We use the platforms like Label or DataView to organize and manage this data efficiently. This dataset served as our foundation for applying the one-shot fine-tuning technique. Pre-processing and training setup. To integrate the one-shot fine-tuning, we adopted the SAM preprocessing method to incorporated the prepare principle from the paper. This involves the resizing the image, converting them to PyTorch tensor, preparing them to the efficient processing by SAM model. In training setup, we loaded the SAM model segment, configured the ADAM optimizer for the max decoder. The one-shot fine-tuning approach guided our selection on the hyperparameter and the optimization strategy to maximize the model ability to ship segmentation tasks. Training loop and optimization. During the training loop, we embedded the images, generated prompt embedding using the bounding box coordinate, fine-tune the max decoder parameter based on the one-shot fine-tuning principle. We optimize the model performance by intelligently adjusting the parameter and evaluating them out against the ground truths, saving the checkpoint and the development. Upon achieving the satisfactory result, we save the fine-tuned model state dictionary. This allows the client to develop the model seamlessly for the SIP segmentation tasks in real-world application. And here is the FAQ. What is SAM? As a SAM is the visual-based artificial intelligence model designed to segment the object within the image. Yeah. Why is SAM fine-tuning important for segmenting model? Fine-tuning is important for any model, not only in the SAM but any model, to adapt the model to the specific tasks or dataset that differ from the original training dataset. What are the common steps involved in fine-tuning? The segment anything, dataset preparation, model initialization, prompt engineering, training and evaluation. Means for fine-tuning any model, we need to collect the data. We have to initialize the model. Initialize the model means lower the initial word or pretend weight of the model. Then we have to do the prompt engineering. Here is prompt engineering is not quite a good word, I think, for here, but it's still in SAM. Prompt means the it is either the point or box and the we give the point and a box. Based on that, the output is the marks of the marks based on that point or the box. Training, the model is trained for that given prompt in the dataset, and we optimize the then the different model parameter are being optimized using the hyperparameter tuning, such as the learning rate and weight decay. You have to specify the other also, and then the model is evaluated, and if the model performance is good in the test data set, then the model is good to go. What prompt can be used to fine tune the segment engine model? There are three type of prompt point prompt, specify the point, and box prompt, specify the bounding box around the object, and based on that model will segment the around the bounding box. Marks prompt, initialize the initial marks, means given the initial marks, rough edges, rough marks, the model can be fine tuned to segment the object. What are the challenges fine tuning segment anything model? Dataset quality. In any model, dataset quality is one of the most important factor. Then computational resource, fine tuning larger SAM require the high memory and computation. Overfitting, if this data is less and we train it for the more epoch, then there is the problem of the model overfitting. And prompt selection, selecting the effective prompt to guide the segmentation process for the specific target application. That means based on the final outcome what we want to our model to give, we select the best prompt for that given task. I think that's it for today. Thank you.